Hi everyone, this is Miss K with a lesson on surface area of cylinders. Today we attempted to find out which aluminum can took the most to make, our regular Coca-Cola can or our twisted mango, which sounds delicious. Between those two, we're still kind of working on that problem and trying to figure that out. So meanwhile, we're going to go ahead and explore how we can use what we've been working on to come up with a formula that will make it easier to calculate surface area of a cylinder. So we're going to start with one example, and we're going to find the total surface area. So when we have surface area, just like we saw before, I'm going to show you how we come up with the formula. To make a can, it doesn't just automatically become a three-dimensional shape. We have two circles. That's our two congruent bases. And then we have this rectangle here. This rectangle is actually called the lateral area. That's important. You need to know that. This is the part that goes around the can. And then these two here are our bases, right? We have two bases. So the bases would be the circular part. The lateral area is the rectangular part. So you could see that you could take this two-dimensional shape, fold it together to make this three-dimensional shape. So in order to find the lateral area, when you're only given two numbers and the two different bases, we have to think about our knowledge of circles and rectangles. So to find the area of a circle, our formula is pi r squared. But we have not one, but two circles. Pi r squared. So our formula here for the first part is going to be 2 pi r squared. That's the two circles. Make sense so far? The two circles. There's two circles. There we go. We're going to add to that our lateral area. And this here is our height, right? Whatever the height is of the cylinder is going to be the height of our rectangle. But then we have this here, okay? Now think about what this would be in relationship to the circle. This dimension here actually wraps around the circle if you were to fold it. So if I were to fold my paper, if you can see, if I fold it, it could form a circle at the top if I did it correctly. So this here is the same as the what of the circle? The circumference, okay? So this is the same as the circumference of the circle. So all I have to do is calculate the circumference of the circle to get the length of the lateral area. Circumference of a circle is pi times diameter. Okay? So the way we'd find the lateral area is pi times diameter times height. So we've got this part of the formula, we have two circles, and then we have pi times diameter times height. So that's how we put our formula together. There's your bases, and then the second part, pi diameter height, or it's 2 pi radius height, depending on what you're given. If you're given the radius, you got to multiply it by 2 to get the diameter. If you're given the diameter, you just use the diameter. I believe the formula on the formula sheet is 2 pi RH. Okay? But you can just use the diameter, or you can choose to find the radius and plug in the formula. So now all we have to do is plug in the numbers. So my surface area is equal to 2. I'm going to use 3.14 for pi times. Now my radius, I have to get by dividing this by 2. So if my diameter is 10, my radius is 5. So that's my two bases. Just 2 times 3.14 times 5. And then for the lateral area here, I'm going to multiply 3.14 times diameter, right, because I know the 10, times the height, which is 15. And just like we did surface area of rectangular prisms, you could do each of these separately, or you could do it all at once on the calculator. Ryan? Square the 5. Yes, thank you. Yes, we need to square the 5. I forgot to square the 5. So now you can grab your calculator and just put all those numbers in. 2 times 3.14 times 5 squared plus 3.14 times 10 times 15. Did anybody else get? Did you get it? 628. 628. And this is square centimeters. Okay, because it's a flat, we're actually thinking about it two-dimensionally, because for aluminum, making a can, it's not three-dimensional aluminum, or you wouldn't be able to put soda inside. It's actually two-dimensional. So that's how you use the formula. You guys are going to be given the formula to use on everything, but it was important for us to look at the Coke cans today and try to figure out how we get the formula before I just give it to you. So let's go ahead and look at example 2. And this time, notice that the question says, find the lateral surface area. So we don't have to find the whole thing. We only have to find the lateral surface area. You're going to have some questions like this to do this week. So I'm going to write the formula. My formula, surface area equals 2 pi r squared plus 2, it's given me the radius, pi r h. Okay? Now, do I need, if I'm trying to find the lateral surface area, which is this, do I need to find the area of the circles? Remember, this is our base, these are our bases, our circles, and this is our rectangle and our net. So do I need, if I just want the lateral surface area, do I need the bases? No. So what you would do is just cross it out. And all you have to do is do 2 pi rh. So we're going to apply that formula. Surface area, or excuse me, I'm going to say lateral area. LA. Lateral area. And 2 pi rh. So it's going to be 2 times 3.14 times 6.5 times 20. I'm going to plug that in my calculator. 2 times 3.14 times 6.5 times 20. Let's see what you guys came up with. So again, I didn't need the first part of the formula because it's only asking for lateral surface area. So the lateral area is 816.4 inches squared. Make sense? You didn't need to, that's another reason why we needed to devise the formula before I gave it to you. So you'd understand that there are two circles. So when you see this part of the formula, if it's just asking for lateral area, you can get rid of it. All right. Let's look at this next example. This gives us a net of the cylindrical soup can as shown below. What is the total surface area of the net? Okay, we can just apply our formula here now that we know it. So we're going to use surface area 2 pi r squared plus 2 pi diameter, not 2, pi diameter times height. Because I didn't need the 2 because it gave me diameter. I checked myself. You see that? I had the 2 because I was thinking radius, but then I said, oh, we have the diameter. So I'm going to use the formula that has the diameter in it. And so now go ahead and just plug in your numbers. Yeah, we're doing the example 3. Comes after 2. And so now I'm going to plug in my numbers. 2 times 3.14 times the radius is 2.5, right? Because it's half of 5. So it's going to be 2.5 squared plus 3.14 times, diameter is what? 5. Height is what? 12. And I can just plug all of that in my calculator. So when you're doing these problems, I totally want you to use a calculator. But I also totally want you to do a couple of things because there's going to be lots of formulas in this unit. We have volume and surface area of cylinders, volume and surface area of prisms. We have volume and surface area of cones, and volume and surface area of pyramids. So I want you to make sure that you're copying down the correct formula from the formula sheet that I'll give you, and that you're plugging in your numbers. You're showing me your work like this. You don't have to show me long multiplication, but you do need to plug in your numbers. So it's 2 times 3.14 times 2.5 squared. That's my circles. I got 39.25 plus 3.14 times 5 times 12. I want to verify this number with someone else. What'd you guys get? You're supposed to be doing this with me. Trying the problems. What'd you get? 227.65. Make sure you guys are doing the practice with me. Don't just wait till later to practice putting the numbers in. 227.65? Okay. So again, all I had to do here was I had to make sure that I came up with the radius from the diameter so that I could plug in radius here, but then I used the diameter, I used 5 when I got to this part of the formula. So now we're starting to get to more practical problems. This is a soup can. We had to pick out the numbers from the diagram. And now we're going to look at a word problem, or more practical problem about Mrs. Johnson on the right and her rolling of the cookie dough. So let's flip it over. So Mrs. Johnson is rolling cookie dough with a wooden rolling pin. If the rolling pin is 2 inches in diameter, how many square inches of cookie dough will she roll in one single revolution of the rolling pin? So there's some information. There's a picture. This gives me the height, right? But what other information do I need about this cylindrical rolling pin? The diameter, and it tells me 2 inches in diameter. So I'm going to label this 2 inches. So my diameter is 2 inches. I know I'm going to need my radius, maybe. I'm not sure if I need my radius, but in case I do, what is it? 1. So my radius is 1 inch. Okay. So I'm going to apply my formula. Surface area equals 2 pi r squared plus 2. I have diameter, so I'm going to use not 2. I'm going to use pi diameter height. Okay? Now let me ask you this. Do I need the entire formula? What is the question asking for? The lateral area. Yes. How do you know that? How many square inches of cookie dough will she roll? When you take a rolling pin, you roll it like this. You don't hit it on the sides, right? You roll it. So the circles of my pen, the bases aren't even hitting the paper. It's just the lateral area. So this is just the lateral area, which is great because then you don't have to do as much work. You can get rid of this part of the formula, and I can plug in my lateral area equals 3.14 times my diameter is what? 2, and my height is what? 12. So it's 75.36 inches squared. Okay, and that's how you find surface area and the lateral area. So we've looked at both. You may have a problem that just asks for the circle. Or maybe you're creating a cup that has no top. So you're only going to use one of the circles. So I'm providing you guys with the formulas. We devised them together, but you guys are going to be working on problems that you're going to have to figure out what part of the formula you want to use. This is a little more challenging than just plugging in numbers, but now you know how to do the basics. And that's it for finding surface area of a cylinder.